Okay, everyone, thank you so much for coming. We're going to go ahead and get started with our 3 o'clock press conference. This is Explaining Extreme Events from 2017 from a Climate Perspective. So our panelists today are Martin Hoerling from NOAA in Boulder, Colorado, Lindene Patton from the Earth and Water Law Group in Washington, D.C., Jeff Rosenfeld from the American Meteorological Society in San Francisco, and Julie Vano from the National Center for Atmospheric Research in Boulder.
Thank you all for being here. I know it's a busy week. My name is Jeff Rosenfeld. I'm the editor-in-chief of the Bulletin, American Meteorological Society. We're very, very excited by this collection of papers. It's covering the extreme events of 2017 because what we're seeing here is a broad overview of what they provide to our readers, and it's giving a very current and future-oriented message, a message that, frankly, many of us are hardly prepared for adequately. We are being asked this week at AGU, what does science stand for? I think you'll find that we're offering some answers to that question with this new release of papers from the Bulletin. And it's not lost on us the irony that we're here in Washington, D.C., where everybody stands for something. If science stands for truth, well, truth is not for everyone. Truth is strong stuff, and it's notoriously complicated. But reality, science is definitely about reality. And the reality is our climate is changing. It's no longer the climate that we thought we knew, and the old reality clearly no longer exists. If we stand for reality, we have a lot to do. This science that we're publishing today, attribution science, stands for something because, frankly, the people using it and the people seeking it out stand for the ordinary business of living smartly. This is our 7th annual collection of attribution papers, and it's a branch of climate science that has been blossoming very quickly, pretty much overnight. Why has it grown? Because of better modeling, because of better computing power, because of better skills in understanding what's going on, clever solutions. But most of all, it's growing because these are the kinds of research answers that people need in the real world. The studies look at what the climate is now, then they run tests to compare it to what the world might have been had we not been releasing greenhouse gases at this rate. It's a calculation of how the risks have changed in the new climate. The risks not just of climbing averages, like global averages, but real risks of real extreme weather that we experience on a day-to-day basis, on a nearly local level, on a scale of days, not necessarily weeks or even months. The conclusions are very stark. Again, this year we have a paper noting a particular extreme, in this case in the Tasman Sea, that could not have happened without human-caused global change. It is a warming, and it's a warning. But together, as a sum total, these weather extremes are telling a story that's beyond just the individual results. The range of papers, for instance, the droughts, the fires, wildfires, the floods, the heat waves, we even have a paper on cloudiness, so on. It goes on. This range of topics, the range of ways of looking at these things demonstrates the range of scientific capability that's out there now. And the research is communicating quite clearly that we have a new world and new risks, and we also have a new capability. We've taken this extra step in the issue, therefore, to look at not just the totality of change, the change in climate and the change in science, but also a change in how people are going to have to live. We're asking people who use the information in this issue what it all means for them and what it means for us as a civilization. The reality is this: the people who matter, the people who build things, the businesses, the banks who pay for things, the insurers, the utilities who underlie all of our capabilities, these people are in it to make a future, and they will not face that future without facing reality. They will price it for us, and in this way they will demand action from anyone who is capable of taking action. They are asking, they're demanding from us, from science, that scientists do more and more in this area. more attributions, more specificity, more careful information, formulations of the way they define these events and model them. At this rate, it looks like they're going to get what they need. The science is changing that fast. The reality is that the science of attribution has given us not just a new climate that we can see, but a new way of living with that climate and foreseeing the risks of that climate. So here to tell the story, Martin Hoerling of NOAA, who was the special editor for climate for BAMS, who oversaw the peer review, and Julie Vano, who's hydrometeorological impact specialist, program manager at National Center for Atmospheric Research, and also a newly elected president of the section on societal impacts and policy studies, right? Science, okay. For AGU, and Lindene Patton, who is a lawyer who specializes in the very kinds of actions that we're seeing increasing in the climate change area. So, Marty?
Thank you, Jeff. So let me just take you a little bit through the 7-year history of this extreme event bulletin special issue of the AMS. And these are the covers of the 7 years of issues. And of course, to the right is the latest issue. And I'm going to speak on the issue of fire, and wildfire in particular is very relevant, of course, in terms of recent events here in the western U.S. What you'll see on these covers are different extreme events that were highlighted by scientists throughout the years in which we've been publishing. And what is very important to recognize in the context of climate change is that many of these events, over 70%, I believe, in what has been published in the 7 years, have been found to have an appreciable climate change footprint. That itself isn't a surprise. The first IPCC report in 1990 indicated that within 30 years, roughly a year or two from now, this is the type of change in weather and climate that we would experience if we continued on a trajectory of increasing carbon dioxide. We have certainly done so, and the consequences are unfolding. Nature's unfolding itself in front of our eyes. So just to illustrate this a little bit further, what I've plotted here for you to see is the summertime global map of temperatures for each of the 7 years that we've been publishing this report. And I've included here 2018 in the lower right there. There's a number plotted underneath each to show the global average for the temperature departure from the 20th century norm. And I think what's important to see here is the colors. They are yellows and reds all the time, every year, in almost all the locations. And so we are in a world that is warmer than it was in the 20th century, and we keep moving further away from that baseline. Even in the 7 years of the report, temperatures have risen about 0.2 degrees Celsius globally. Doesn't sound like much, but as we'll see, it makes a big difference, and it's the incremental differences that matter because there's a nonlinear relationship between the impacts and the economic concerns that arise from these types of warming patterns. So we had 2 events I'd like to highlight. Both of them speak to drought and fire. One of them was studying the Northern Plains drought of 2017. Now, to let you know, there is currently little drought left in the Northern Plains in 2018, but that doesn't make the story any less important today because, as you'll see, we have a situation in the American Southwest that isn't going away, and we've, of course, had these tremendous fires in that region. So here's a picture looking in central Montana at the devastation that was wrought by what was called the Lodgepole Complex Fire. About 200,000 acres burned. Just replacing the fencing for the ranchers was over a $20 million hit, let alone the fact that ranchers cannot return to these landscapes because of the fire. 2 studies were done. Andrew Hoyle led from NOAA and Hailan Wang from NASA contributed 2 nice studies. Here's just an illustration of what the map of drought looked like in the summer of 2017. And you can see the reds highlight Montana was in the epicenter of that drought. A key part of this story really isn't climate change, but I'm going to come back to that. A key part was that precipitation was much lower than normal, which is the time series you see in the lower left. You see greens for wet years and tans for dry years. In 2017, the drought was principally because precipitation was low. This is a Weather Service challenge. This is a forecast challenge to anticipate the precipitation. However, what was also discovered in the science that was published was that temperatures have warmed, and the effect of warming temperature compounds the effect when dry, low precipitation years arise, like they have from time to time. And in particular, the study highlighted in our report finds a 50% increase in the frequency of a drought of the intensity that happened in 2017 because of the background warming and climate. And you just saw that there are very few places escaping from the warming that's occurring in our planet today. Now you might say, well, Australia, that's pretty far away from the northern plains of Montana. It's certainly very far away from Palisades, California, where we had the fire just recently. But I'm going to tie those together with the evidence that was presented in these two studies with what we see happening today. So the Australian wildfires also covered something on the order of 200,000 acres, near record proportion. Again, very similar rangeland destruction. Fortunately, not as much devastation in terms of a loss of life, so we're grateful for that, but that's not the experience in California this year. The backdrop on that one was shown in the large map is the index of fire danger. That's a sort of compound of factors that includes soil moisture and the daytime high temperatures and the relative humidity and the wind speed. And coming into the summer, which will be February, if you will, 2017 in the southern hemisphere, that condition was achieving catastrophic levels. And triggers happened in this case, and the fires burned. This is an area in which there's been a long-term trend shown in the inset picture, where you see yellows and oranges, an upward trend in this fire danger index, principally because of an increase in temperature and a reduction in relative humidity. That's the backdrop for the climate change story in this. These scientists that study this, Pandora Hope from the Bureau of Meteorology in Australia, used a rather sophisticated modeling method that uses forecast systems, if you will, to do the attribution. And what they found was that high temperatures and low relative humidity made this situation, this high fire danger, more likely than had climate change not been occurring. But they also pointed out that other factors were at play and that the climate change contribution was small compared to the other factors. And that's important to keep in mind, that we are not just talking about climate change driving weather. Weather is still being driven by the types of fluctuations that distinguish between us waking up and wearing a coat and not wearing a coat going out the front door. These are still forecast problems that we have to deal with. However, there's a backdrop that's changing and making these situations more likely. Now, the Palisades, California fire, Camp Fire it's sometimes called, I believe it's 18,000 homes perhaps, or structures were destroyed. And of course, the loss of life was innumerable, on the order of about 100 or so as we speak. The conditions, were they similar? In fact, they were. The conditions that promoted this fire were very similar to those that promoted the 2017 event studied in this annual special issue. Just to give you a little bit of backdrop, and this is work yet to be done, so I'm just giving you a flavor of what the understanding of the 2017 studies tell us about the California situation. This is the latest indication for the drought conditions shown in the big map. The darkest reds there show the four corner states under severe drought conditions as we speak. And then the inset shows the time series for temperature in California. What's amazing about the California temperature time series is there has been virtually no hiccup in the upward trend, and every year since 2000 has been warmer than the 20th century. It's just a movement of the global system that's reflected here in California temperatures. So each year when you come into the end of the summer season in California, it has been warmer all year long, and so the conditions are more ripe. The fuels are more tinder-like if a trigger happens, and inevitably a trigger happens as it did in the Paradise Fire. So I wanted to bring this picture up, which some of you may have seen in a more popular literature. It came out in The Economist magazine about a few weeks ago. A study that was published in the Proceedings of the National Academy of Sciences, not in our BAMs, but it speaks to exactly the lessons learned from these extreme event studies. What's interesting about this is on the x-axis is temperature and dryness becoming warmer and drier as you move toward the right. And then on the y-axis is the southwest area burned due to fires. And what's key about this figure to take away is it's not an incremental one-to-one relationship. And there are tipping points implied in this, that at certain levels you see an acceleration of the amount of area burned as the dryness index begins to get greater and greater. And these are the important aspects of why these extreme events need to be studied with care, to identify these tipping points and to better understand where we are moving over thresholds that take us not from incremental 1 degree warming, 1 increment additional danger, but these rapidly escalating dangers to society. So I think with that, I'm going to move it to Julie, who'll talk about water abundance rather than too little, huh?
Yep. So I'm Julie Vano. I'm from the National Center for atmospheric research, and I had the good fortune of being a part of a team of folks from the American Meteorological Society Water Resources Committee, and they're folks from federal agencies, from consulting firms, from public utilities, and from academic institutions, and we put together a perspective piece looking at hydroclimatic extremes as challenges for water managers. And really the key take-home is that attribution studies, when focused on water management concerns, can help water managers navigate record-breaking extreme events. And so we looked at two different case studies that were two periods of heavy precipitation and high runoff that exposed dangerous weaknesses in water management infrastructure. And this picture is likely familiar to many, the Oroville spillway with the damage that occurred and the evacuation. And from this, it was a series of large, intense precipitation events, atmospheric rivers. 49 made landfall in this particular season, which is about twice as much as what normally happens. And so that was a big part of what led to this event, although it was also that the temperatures were warmer. So the water from these atmospheric rivers didn't stay as snow. It was already in the reservoir, so it caused the reservoir to be full already, and so operating it through this damaged spillway was particularly challenging. So temperature plays a role in the magnitude of these events. In addition to the temperature and the precipitation, the meteorological forcings, there's also the operational factors, and Marty mentioned this a little, that are really important in most extreme events. And so had there not been the damaged spillway, we probably wouldn't have even heard about how water managers were able to navigate this extreme event, which alludes to the fact that there are lots of other reservoirs out there that were really close to overtopping as well. And managers are really great at doing their jobs and were able to navigate this as long as there wasn't an infrastructure challenge, which there was one, but in the committee, we were really holding our breath through that season, knowing that there were a lot of other places that were close to being at risk. And with aging infrastructure and more development happening in places where there's risk exposure, we really need to think about how we manage our systems. Another case study we looked at was Hurricane Harvey, and here the lesson was that the duration often determines the event severity. So often when we're thinking about designing infrastructure, we think of the probable maximum precipitation, but it's really kind of this longer duration, larger area events that we really need to understand better. And the forecasts for this particular event were actually pretty good, but water managers saw those forecasts and they were so outside of their experience and what was in the historical record that they didn't know whether to believe them. And this really drives home the point that attribution studies can help management navigate this new paradigm shift if they're designed to address the questions that keep the water managers up at night. And in order to do this, I think it requires an understanding and a dialogue between the science and the management community. And there's progress in kind of connecting these communities, and hope to see that moving forward into the future. And so I want to emphasize, again, some of the challenges the water management community is facing. And here's a quote from Lexi DeFore, who's at San Francisco Public Utilities Commission and also in the room back there if you want to talk to him later. But water management projects such as dams are optimized for design events of specific likelihood estimated based on historical records. And the questions are these designs still valid? If not, how much are we wrong? And what are the potential risks to public safety? And again, this alludes to that attribution science can provide more information and context for understanding forecasts of extreme events that are beyond our historical experience. And again, I want to emphasize this was a team project, and happy to talk more, but there's also 4 people sitting in the back over there that were a part of putting this together from, again, lots of water utilities, consulting agencies. And so if you guys want to just raise your hands so people know, Dave Curtis, Rob
Sitting together.
Sapelli, Anna Wilson, and Alexi DeVore. And that's all. I'll pass it along.
Great, thank you. I had the privilege of continuing some analytical work with Client Earth, which is an NGO focused on climate change and legal applications. We specifically looked at how attribution science could be used to inform the analysis of liability for a variety of actors within society. Generally, what society and courts want to know is, should you, if there is a damage, a severe event, and people are displaced or their assets are damaged, should you have seen it coming? Could you have anticipated it? Was it foreseeable? And if the answer was yes to any of those questions, what practical and sensible steps should have been taken to prevent or mitigate damage? The take-home message that we would offer from the analysis that we have done and continue to do is that attribution science and technology has now progressed to the point where the statistical certainty, which is emerging from attribution science analysis and models, will change the duties, obligations, and inform the analysis of liabilities of facility operators and owners, designers and builders of infrastructure and other assets, and professionals who advise them. Best practices are and will continue to change in response to this ever-increasing statistical certainty of attribution science. We set out to try to understand why would a non-scientist be interested in the whole concept of attribution science. As I've noted, and I think as some of the other panelists, Julie has noted, facility design criteria are absolutely informed by scientific information. If attribution science is here and telling us in no uncertain terms with statistical certainty that is more likely than not, which is the legal standard, that our experience with extreme weather events is going to be one of more intensity and, in some cases, greater frequency, then the standards of building and the best practices that inform those who render those standards must change. The performance and reliability of our assets are impacted by weather, extreme events, and other changes over time, including climate change. And it's no surprise then that attribution science can inform and climate change impacts the design criteria, the obligations of professional operators, governments, and directors and officers. In a legal context, if you want to understand what an obligation, let's say in a negligence environment is, you need to identify who had a duty, if that duty was breached, what was the cause of the losses that are being claimed, not only the cause in fact, but the proximate cause, and what were those damages? Were those damages directly related to that breach of duty? But the clear and most important place where attribution science is informing this analysis is the issue of proximate cause. Most particularly, the statistical certainty of the attribution science, which is now emerging from a multitude of events, is that it is possible to forecast and it is foreseeable that we will have more increased and intense events over time. So if you were to look at a series of the events that are really important, what is new? What's new is that the statistical certainty has crossed the line where it is legally important. It is more likely than not in many cases. That sufficiency of certainty for decision-taking differs in a court of law and science. And so it's important to keep in mind that perfection is not required in an adjudication environment. You just need to know what's more likely than not. The impact of this change in scientific certainty is going to inform the negligence analysis, and it may also inform other statutory liabilities. There are practical implications and outcomes which will emerge from this improved attribution science and technology, and the actions that must be taken to satisfy the obligations that are created with these new and informed duties for people who work in these areas may include changes in design, changes in management, changes in investment. retrospective analysis and assumptions that the past will predict the future may no longer meet the standard of care. There is, in fact, litigation which is looking at these issues in particular. I don't have time to review all of them in this press conference, obviously, but if you have any specific questions, we can take those offline. But I think from a diagrammatic perspective, what's important to understand is that as foreseeability increases, once you cross that line of it is more, the science says that an increased event is more likely than not, your liability exposures increased in a step change manner. So once the statistical certainty exceeds 50%, there's a threshold shift in the duty of care. The integration of attribution science into modeling is required when that change shifts, and the attribution science then can inform modeling outcomes, which can inform professionals and facility operators to take particular actions. Yes, there is ongoing litigation. Yes, there have been a series of demands that have used a variety of climate science. I would note for you that I'm not talking about emitters' liability. I'm talking about liability associated with professionals, with all manner of parties in the society to respond appropriately to what attribution science is telling us with statistical certainty about the environment in which we live and the environment which is likely that we're going to live in the future. And it's very clear that the statistical certainty that is coming out of this attribution science is in fact allowing forecasting. It's allowing comparisons from what would be without anthropogenic or human emissions to what is with those human emissions. And we're able, with that statistical certainty, to compare and contrast what would have happened to what did happen or what's going to happen. And that's the kind of information that will inform an analysis in a court of law. It's not just a court of law either, though. On a more practical and sort of important note, in my opinion, in a lot of ways, is that professional groups that do design criteria, like the Association of the American Society of Civil Engineers or the American Institute for Chemical Engineers, now have active task force in place who are evaluating the impacts of the change of climate science on their own best practices. They are recognizing that their best practices must change in response to the developments in climate science, and particularly to those developments in response to developments in attribution science and related technology. So that's the take-home message, is that this science is going to change our obligations, not just as scientists, but as all sorts of social actors. I'll turn it back to you.
Thank you, Lindene. Do we have questions? I think we're ready.
There we go.
Hi, my name is Omer Irfan. I'm a reporter at Vox. We also saw this year some attribution efforts in real time or close to real time for Hurricane Michael and Hurricane Florence. I'm wondering if you can comment on the value of trying to do these attribution studies in as close to real time as possible, what their limitations are, and what we gain by doing a retrospective more thoroughly like you're doing now.
Let me start. It's a really good question. I'll use the NTSB analogy. So plane goes down, and immediately you want to know, well, what was wrong with that, because I'm booked on a similar aircraft the next day. And you may be learning that, well, it was bad weather, maybe something about the environment speaks to roughly what could have been a factor, but you don't know. A year later, maybe 2 years later, you finally get the report, and this report you embrace because you know it's been vetted, it's gone through the careful analysis of experts. That's the difference between something that goes out to fill the airwaves the day after the event and the final report that speaks to the causes. So it really depends on the user at the end of the day.
Seth Borenstein, AP for Marty. There's at least one of the 17 extremes you're looking at is low sea level Arctic sea ice levels compared to the Western European heat wave, I think it is.
Drought, I think.
Drought,
yeah.
yes.
Drought,
Also in 2017, you saw record low Arctic sea ice in the Bering Sea. We're going to be hearing about that tomorrow. Can you tell us a little bit about the connections we see using attribution science between what's happening in the Arctic and extremes more our neck of the woods.
So the particular paper you speak to used a forecast system, just like NOAA would run a weather forecast model, and they tried to make a forecast for the drought, if you will, retrospectively, in which they used a forecast system with all of the information from which you would launch a weather forecast, and then they ran it again by withholding one piece of information, one piece only, which was the extent of the sea ice loss in the Barents-Kara Sea region. And they had to run this model 100 times in order to detect an impact on the precipitation for, I believe it was February of 2017 in Western Europe, and found a statistical effect that it was drier because of the inclusion of the sea ice condition. The notion here being that the sea ice was depleted because of climate change. So there would be, using a forecast system, an attempt to connect climate change in a faraway location with a weather pattern that led to drought. All of the details of that are yet to be unraveled, to be honest with you, Seth. At this point in time, the science on how is the Arctic affecting places like Washington, D.C., Omaha, Nebraska, and Sacramento, California, is pretty much still in development. Most of the effects that we are confident about is that when the Arctic warms, the air masses that move down from the Arctic into the United States and other continents and mid-latitudes are not as cold. So there's less extreme cold temperature variability, if you will, in relation to a warmer Arctic. And that's probably the most definitive aspects of what we know about the Arctic. But within the Arctic, of course, the changes are dramatic. And I don't have to tell you all the details about that. NOAA has an Arctic report card that'll speak to that, I think, during the course of the week. It's really quite stunning. So hopefully you can attend that.
Do we have more questions from reporters in the room? Do we have any questions on the chat? No? That's it? Oh, yep.
I found I'm Mary Miller from Exploratorium. I found this notion of, using the courts to adjudicate this attribution really interesting, but sometimes it's a matter of percentages. So how does that work out? It's 10% worse than it would have been, so, how would you imagine it could play out if it's not, you said it's, foreseeable, but who's to blame?
So it's actually a really good question, and maybe it's best answered by discussing an example, a theoretical example. If you were a facility owner and you had a chemical facility that was on the edge of a river, you have certain levels of statutory obligations to prepare for emergencies. And those emergencies have to make assumptions about storms, maybe storm surge, perhaps rain, and you have to build your facilities to assure that releases of chemicals don't come from your facility based on certain statutory criteria. If your calculations are done assuming 1970s rainfall events, which many historical best practices for engineers do use, then your design would not be prepared for today's climate. When that attribution science has sufficient certainty to show that you need to have a different set of rainfall tables, then if you don't use that different set of rainfall tables and a chemical release occurs, then you may find a claim is made against you arguing that you should have done that. They can be much more complicated. Who has standing to sue is more complicated. But that's sort of the general idea. As another example, if you wanted to, let's say in the state of California, build a housing development. In the state of California, developers are held to very high standards for defective construction. And if they were going to build in an area which is in a floodplain, a known floodplain, like let's say a rice paddy field, and that's been a rice paddy field because it's always full of water, right? But it's not a FEMA 100-year floodplain. But the current climate science absolutely tells you that it is going to flood on a recurring basis, at least every 5 years, if not every other year, or all year long. Then if you build in that location and don't take appropriate steps to prevent those homes from being flooded, and yet you sell those homes to all of the new owners, those new owners might have a really interesting claim against you and the architects and engineers for having failed to incorporate legitimate science in a manner necessary to achieve best practices or to meet your baseline duty of care. So I think the applications are very significant and very broad spread, and it's a very different way to look at the value of the information that's available from this attribution science, not to look at emitters, but really to look at what many actors in society should be doing in response to this data, and how they ought to apply it in a way that can help us make us more resilient.
Do we have another question?
I'm curious, could you, Eric Neeler with Wired, I'm curious about on coastal building, are government entities updating these things? I mean, can you, you know, it's very nice for a home builder, but I mean, I don't know, the agency that controls all the building permits along the coast, are they?
Yeah, it's actually a really, the whole issue of national and subnational government responsibility is a different specialty area practice of law. They are responsible for making certain decisions, but the basis for their responsibility is typically derived in a statutory context. There is some common law. And you have to look at what record they must consider to make their decisions. This is true not just for people who are making building code decisions, but people who are doing things like making decisions about what public utilities should be allowed to pass through as costs for improving the resiliency of infrastructure, so that maybe the utility can deliver power consistently when the waters rise and the wind blows or the fire rages, right? So you have to really look in those contexts very specifically at how the authorities run to each one of those municipal authorities, and then determine what they are obliged to look at. And then from a science perspective, that attribution science has to be placed in the records that they must look at. Now, if they're obligated to come out and look at the general scientific literature, well, okay. Or if they hire a professional who has to look at the general scientific literature and incorporate it, okay. If not, you got to get it into the record. And I would commend your attention to the events involving Con Ed and the New York Public Utility Commission and the Columbia Law Center post-Sandy to look at how climate science information was pushed into that decision-taking process. Not exactly efficiently, but it got done. And there are a few other examples that might be considered. You can look at what's going on in California with the fires, and that is a story that is being written as we speak.
I think that also speaks to this general progression that we're seeing by looking at large groups of these papers at once over 7 years, is that the first papers that we got for this issue generally were larger scale events, and they were generally on longer time scales, like you might be looking at month-long anomalies or seasonal anomalies and trying to give attributions for those. But the decision-making bodies are at a different scale. Obviously, building codes can be very local, but there are certain statewide agencies and regulations involved in certain things, or regional consortia that look at things. So as the papers now are starting to get down to these levels of events that are on the scale of the decision-making bodies or the regulatory agencies, I think that's where you're seeing that step function too, not just the percentages, but
yeah, and
scale of the event.
I think you heard Julie talk about it with the water utility, managers. They're having to take this into consideration. So I don't look at the law only as a negative, way to go hold someone accountable. I look at it as a mechanism for communicating what society expects, and then that's used in most of my practice to communicate to people what they need to do to have good risk management practices. So one would hope that that information, that science is used to inform good risk management practices. Maybe the driver is ultimately the threat, that you would be taken to court and accused of negligence and held accountable for damages that you could have prevented had you considered the attribution science. But to me, that's the bad end of the road. But the law is useful when these standards changed, and this is not the first time we've seen it. As the science emerged in the pollution area in the 1970s, we clearly saw a development and emergence of liability, first against professionals in the private negligence area, and then the facility area, before there was a much broader adoption societally about how to respond to pollutants. So this is not a new process, it's just a new science.
Okay, do we have any more questions from reporters in the room? Yeah, back here first.
Thanks. Hunter Cutting from Climate Signals. And this is a question for Ms. Patton. You're probably following the current debate before the California Coastal Commission, which is considering a policy to mandate managed retreat for seaside communities in the face of sea level rise. And one of the interesting pieces of law there is that in California, public waterways are public, not private. And so we have this interesting situation where with sea level rise, private land will become public, and you sort of have a de facto eminent domain taking. And I'm wondering if you can comment on what that will mean for how the legal system will deal with this bizarre situation.
Yeah, I will make like a really short comment. This is a completely emerging area, and I don't think there's a lot of rules set for that yet. They're going to be making some rules, but it does sort of beg the question of, is a fact, right? Because the land was there, and then the land is not, and then whose is it? It presents us with a social challenge. The law system is designed to deal with adjudicating social, disputes, and so it's going to have to come up with a solution one way or another. But I don't think it's going to be fast. That one's tough. It's worth a lot of money, and it's people's homes, which is even more emotional than the money. So, tough one.
Okay, I think we have time for one last question. Does anyone else have one?
Kit Stoltz for Martin Hoerling. Dr. Hoerling, in your brief discussion of the Australian wildfires, they seem to have a new metric, is that right? And if so, could you compare it to the kind of red flag metric we have now?
So the metric that they were using was a product of different physical processes that are relevant for forest fire risk. So their forest fire danger index was a product of these various properties. It's pretty much a synonymous with Byron Keach type of index, different indices that have been used in the U.S. This is just a different way of sort of illustrating the formula, which I just showed as a product of these factors. But those are the essential factors. You need to have the soil moistures be low, temperatures be high, the winds be high, relative humidity be low. Those are the key ingredients to fire for the fuels that would burn. Of course, that's what connects these fires happening. Australia's been seeing a rampant increase in wild fires, as the western U.S. has been. Not all places in the world. There are land use changes that intervene. Some places in the tropics are seeing less wildfires because of the way they're changing their land use practices. But in areas such as the western U.S. and also in Australia, and Canada, we're seeing a significant increase in the areas burned. So the fact of the matter is this is fostered by a lot of different factors, but one key is the fire danger index is rising. So even if you have the same triggers, whether it's lightning or just human accidents, you're going to see more and more intense fires burning. You could also have more triggers without changing the fire index danger and also see this outcome. That's where some of the complexity comes into parsing those apart. It's part of the attribution struggle in that regard for fires, which is a complicated beast.
Okay, I think we have one final question from the chat.
This question is from Steve Baragana, Voice of America. Previous reports have had more examples that have not shown an impact of climate change. This year has almost all yes answers. Can you speak to why?
Well, I'm going to give you just one quick, and that is the first slide. The planet continues to warm and move us further away from the situation of the first report that we published in 2012. So what's happening is that the system is showing its hand. It's beginning to reveal its true sensitivity. So the facts are emerging without having to be too sophisticated about what are the physics behind it. We don't have to conjecture, we see it. Nature's providing us the evidence. So this is the pace at which climate is beginning to change. We are seeing it manifested in extreme events. The majority of the ones that were published, but not all of them, showed a discernibly large increase in their risk, their magnitude, because of the warming planet.
Thank you.
Okay, that's going to wrap up our press conference, but all the panelists will be available for questions afterwards too, and we'll reconvene at 4 o'clock with our first geoscience grab bag.